Okay, so this is part 2 of the MEMS PolyMUMPS design rules guidelines. So if you remember before, we were talking about how we have to overlay things properly and follow specific design rules. So you can see here, this is one first step at it. You can see we've got a structure that's a hole. Okay, we've got another structure that's a poly structure here. And if you look at the hash marks, you can see that's poly 0, okay? So this here is poly 0, right? This this other hash mark here, which I'm going to color blue, is oxide 1, okay? So this is a really simple first step. You can see that on these design rules, the oxide hole, the blue stuff is the oxide, and the opening with the arrow is the hole. That's denoted by this structure here. Can you guys see that? Okay. So it's kind of hard to tell if we look at this line, and I'm going to highlight it with a green. This is a cross section. Right? We cut across where it's green, and that's what it looks like when you do that from the side. And this takes a while to get used to. Okay? If you've never done this before, it's not easy. That's why I go over it and over it and over it. Okay? So when I cut across this structure here, I get this side view. Okay? Can everybody kind of see that? Right?
When you the software, can you see both views or one view at a time?
You see pretty much when you're designing, you see the top view. Okay, and then you can do a 3D model and cross section, and we're going to do that today with the cantilever. Thank you. We're going to do that with the cantilever, and then we're going to show you how to do that 3D model and cut it so you can see it from the side like this.
Something that geology does a lot when they do diagrams, they'll label the line. So this green line you have there, they might have it labeled A8 prime, and then you realize that the line that you see up, then you see the top view or the cross section is the line.
Well, that's the general way that they do it. So if you look at that, these little arrows here and the line, the black line that goes across, that's indicating where they cross sectioned it. And this is really handy to look at. So you can see there's 2 design rules that they're trying to show here, right? Can you guys see that? There's this B design rule and this A design rule. So what are those? Now let me see if I can move down. And this is how the design manual is laid out, right? So you can take a look, and here's A. And here's the B description. So what does A say? It says poly 0 space to anchor 4 microns. So A, here is A. So this is poly 0. Okay. And this is an anchor 1. So you can't put an anchor closer than 4 microns to poly 0, or you have to put it totally on top of poly 0 and have B as the tolerance. So B, okay, says poly enclose anchor 1. So poly 0, that's this structure, okay, poly 0, has to enclose anchor 1 by at least B. So you don't want to make your anchor closer than 4 microns to any of the poly 0 edges if you're anchoring to poly 0. Now you might want to anchor to nitride for some reason, and then you would put a hole out by itself. If you do that, you don't want that hole in anchor 1 to be closer than 4 microns to the poly 1, or poly 0, excuse me. So does that make kind of sense? And if I scroll back up, okay, you can see what's happening here, right? So we made a hole here on top of the poly 0. So here's an anchor 1 hole in the oxide one. And we got to have at least what? How many microns here? From the side view? 4. 4, right? And then we made a hole here and a hole here through the oxide. But we can't make this hole or this hole closer to the poly 0. So this distance here, from here to here, has to be B, right? That's what you see here. This is B, this is B. Actually, this is B. And this is A. Okay? So that was, what was A? I think it was 4, right? So that's how you interpret these kind of pictures when you're drawing. You want to say, okay, am I breaking any design rules? And you're going to be graded on design rules. And I think there's a design rule checker. We got to figure out how that works, right, April? Have we?
I have not tried it yet.
Yeah, so that's something, that's our next project that April and I have, is to figure out, because there's an automated way for the machine to check that for you. But I think the first few designs you make will be simple enough that you should check it yourself and get that in your head and not rely on the machine, because sometimes the machine misses things. So these are the standard methods that they use to display the design rules. Okay, so you have a cross-sectional view on top, then you have a top-down, which is what you would see when you draw it, and then you have the rules that are associated with the letters, A and B in this case. Okay? You getting that? All right. All right, so here's the next one. What is this? Ah! So here's our poly 0 again down here. Okay? We made our hole in the oxide, the anchor hole. And then what is this stuff? This is new. What do you think that is? The hash is poly 1. So this is poly 1. So the hole we made in the last slide, we just filled it with poly 1. So we're connecting poly 1 to what? Poly 0? You agree? Mm-hmm. This guy here? So we're connecting this poly to the poly 0, which is what you're going to do with our cantilever, right? You're gonna draw a poly 0 pad. You're going to make an anchor inside that pad, and then you better have at least 4 microns on each side. Right? That's the hole. The hole will land on the pad. And then you'll put the poly 2 on top of that. It'll fill the hole. And then you'll define what your cantilever looks like. Okay? Does that make sense? So it's going to kind of look like this. I hope I don't make any mistakes. But you're going to have your, give me some space to draw here. You're going to have your poly 0. Okay? Then you're going to draw your anchor 1. That's what it'll look like, top down. Okay? This space right here and here has got to be at least 4. It can be bigger. Make it 10. I don't care, right? And then you're going to draw the next layer. Let me pick another color here. Oh, let's make it purple. Okay, and then you're going to draw something in poly 1. Okay. There's your poly 1, and it's going to continue on that way. Okay. So what's that going to look like when you look at it from the side? Well, it's going to kind of look like this. Right? Kind of hard to see. Okay? It's going to connect. So the purple is going to connect to the red through the hole you made in the blue. Okay, so what does that mean? Okay, poly 0 structure is your pad. The blue structure is anchor 1. That's the name of the layer. And then the purple structure is poly 1. So anchor 1 makes an anchor from poly 1 to poly 0. It can also make an anchor from poly 1 to nitride if you don't have a poly 0 under it. Okay? So are you guys good with that? I hope. So you can see we're going to keep building stuff. So what did we add? What's different about this one? You got this structure right here. See this new structure we didn't think about before? And this structure is different. Right here. Okay, so this thinner blue structure here is the oxide 2. So we talked about oxide 1, we made a hole in it. We could connect poly 1 to poly 0. Now we got oxide 2. Oxide 2 can go on top of poly 1, or it can go on top of the oxide, depending if you drew something in poly 1 or not, right? Most of the time you don't. So oxide 1 and 2 usually are on top of each other. Okay, then you can use anchor 2, okay, to make a hole through oxide 1 and 2. Okay, and then you can fill that hole that you made through oxide 1 and 2 with poly 2 and connect poly 2 directly to poly 0. That's what this is showing. Okay, so this structure here is the hole here. Okay? This structure here is the poly 2. And this bigger structure here, what do you think? What is this? Poly 0. So you guys are getting it, right? That's another way. You can make your cantilever in poly 2 and anchor it all the way down to poly 0 if you want to. That's okay too. All right? And if you look at the design rules for this one, it says poly 0 encloses poly 2 by 5 microns. It's not 4 now, it's 5. So let's take a look at that. Poly 0 enclose poly 2. So which one's bigger? Poly 0 encloses. So your landing pad has to be bigger than this structure that you're connecting to by at least 5 microns. Why? Why is it 5 and not 4 like the other one? Any ideas? I know it's been a long day. Any ideas? Because poly 1 to poly 0, you only had to be good to 4 microns. But poly 2 to poly 0, you need more space, right? More envelope. Why? Because you have more layers between. It's harder to align. Okay, as you add more and more layers, like when I was at TI, we had like 27 layers on some products. Well, when you're at layer 25 and you're trying to align to layer 4, it's really hard to do because you got all this stuff in between and all this topology. So the alignment tolerances usually get bigger and bigger as you get further and further along the line because you can't align as well. You've got all this other slop in there from the previous layers in between. Okay, so that's why that that tolerance is bigger. Okay, so that's why it says poly 0 enclose poly 2 5 microns. So if you're going to do a structure like that, you better have more gap. And then poly 2 encloses anchor 2 by 5 microns. So they're both 5. Okay, so that means D, and I don't know what this is, J, D and J are both 5 microns. Okay, so what's J? J is from the hole to the first edge. So let me see where J is. J is right here, from this to this. And that's going to happens to be the same as from the poly 1 to the poly 2, or the poly 0 to the poly 2. So if you draw a line down here, okay, it would be this distance. This distance right here. That's what D is. And you can see how they line up, right? So this structure's edge and this structure's edge has to have at least 5 microns. If you look at this one, this structure's edge and this structure's edge, this one and this one has to be at least 5 microns. And if you look at it on this side, right, this is at least 5, this is at least 5. Can be more. Those are the envelope rules. So is it starting to make a little sense? So you're going to use this manual a lot, so keep it with you. We might, if you need to, we can print out a few more copies and leave them in here. Okay, and have your own, scribble on it, you know, that kind of thing. Okay, and I'm trying to see what else. A whole bunch more slides, and I'm not going to go through each one of these. See if this is interesting at all. So you got poly 0 encloses anchor 2. I'm reading that right. And then poly 0 space to anchor 2. So that's E and F. Okay, so there's a hole that can't be closer than F to, again, poly 0. And we had that hole before with anchor 1. Now with anchor 2, it's the same set of rules, except they say, well, I want 5 now, 5 microns instead of 4, because you're further away when you start drilling down.
Somebody changed the password, the admin password.
It's not Stephen 10 lowercase?
No.
Ooh, that's not good. Well, we'll figure that one out. I don't know what happened there.
Internet, we'll learn to teach how to hack.
We'll have to figure out how to hack it. But we've got enough computers for everyone, so we only have 5 in the class and 3 in this one. So I think we'll be okay if one machine's a little squirrely. Hopefully I can get Dr. Lessman to get a grad student to clean all these up after the semester, and then have 3 with their licenses on there, and then get everything back to normal. Okay, back to the task at hand. We've got these holes. So this hole can't be too close to the pad, or it's got to be on top of the pad with enough tolerance around it, right? So this is 5 microns instead of 4. So anchor 2 and anchor 1 are exactly the same in terms of their tolerances, except you're doing 5 microns instead of 4 because you're further away when you make the holes with your lithography tool. Okay? And on, right? It gets more and more complex. So I think I'm going to stop here, because you guys got enough to be dangerous, and I want you to play with the software, right? We've been itching to do that for a few weeks, so I'll shut up now.